In the previous class, we were discussing about the architecture of 8051, and there we discussed about ROM and RAM, and we discussed that 8051 has 128 byte of RAM. Understood? Byte stands for byte means 8 bit. 1 byte is equal to 8. Now, in this class, we will look at the architecture, or you can say organization of RAM, that how these 128 bytes are arranged or organized in 8051. So the by 128 byte of RAM can be accessed with an address starting from 00 to 7FH. Now this H here, whenever you see H in 8051 code, this H means hex value. Understood? H stands for hex. And this 128 byte of RAM can be accessed via this address, and address starting from 00 to 7F. So if we convert, we know that this hex is basically a base 16 number. If we want to convert this into decimal, base 10, then it is very easy for us is to convert it 7 multiplied by 16 plus F is equivalent value is 15 in decimal. So this is actually equal to 127. So if we start from 0 and go up to a value of 127, which means it will give you a length of 128 bytes. Now these 128 bytes are divided into 3 parts. The first 32 bytes starting from an address of 00 to 1FH are set aside for register banks and stacks. Whereas next 16 bytes starting from location 20H to 2FH are set aside for bit addressable, and similarly remaining 80 bytes are starting from a location of 30H to 7F are used for read and write storage, or also called a scratch pad RAM. Now here we will discuss about first 32 bytes in this class, about register bank and stack. Understood? So if we look at the architecture of this 8051 RAM, here we can see the first 32 bytes starting from an address of 00 to 1F. And if we look at this thing here, from 00 to 07, it is called as register bank 0, and from 08 to 0F, it is called register bank 1, and then from 10 to 17, register bank 2, and from 18 to 1F, register bank 3. So it means this register banks of 8051, each register bank has a size of 8 bytes. Understood? 8 for register bank 1, 8 for register bank 2, 8 for register bank 3, and bank 2 and bank 3, which means a total of, if we make a sum, so we will get a 32 bytes. Understood? And these register banks are basically addressable by using those addresses that are given on the left side. We are given the lower limit and the upper limit. The lower limit is starting from 0 to 07 is for register bank 0, and address starting from 08 to 0F is for register bank 1, and same for register bank 2, and same for register bank 3. Similarly, starting from an address of 20 to 2F, we have a 16 bit, 16 byte bit addressable RAM. These are used to store bits of information, okay, in bits, like conditions or something. We will discuss this thing in detail in input-output section when we will write our first program, inshallah, about switching an LED on and off. So there we will discuss this bit addressable RAM. And the next 80 bytes are scratch pad RAM. This is for general purpose, read and write in RAM section. Understood? Now, coming back to our register bank, first 32 bytes. Now we will look inside that what and how about these 32 bytes. So these 32 bytes are divided into four banks that we discussed earlier. These four banks are register bank 0, register bank 1, register bank 2, and register bank 3, in which each bank has 8 register. Means now further classifying that if we have a bank memory bank starting from 00, in other words, first register bank, and coming to 07. So actually, these 8 bytes, as we discussed in previous slide, that each register bank has a size of 8 bytes. These 8 bytes are further divided into 8 registers, starting from a value, a number, a name of R0 to R7. Understood? And size of each register is 1 byte, which means at 00 we have R0, at 01 we have R1, and up to 07 we have R7. Understood? And each register has a size of 1 byte or 8 bits. And these registers are also called JPR, General Purpose Register. Understood? We will discuss this thing in detail, that what are JPRs and what are SFR. SFR stands for Special Function Register. Similarly, register bank 0 is the default when 8051 is powered. Which means by default, register bank 0 will be selected whenever you switch on your 8051. Understood? By further looking into the detail about the architecture of these 32 bytes, here we have a pictorial representation. Starting from 0 to 7, we have, this is actually register bank 0. Dot, 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 register bank 0, register bank 1, register bank 2, and register bank 3. And starting from an address 0, then R1, then R2, then R3, then R4, up to 7, then 8, and then 7 goes on. Understood? Now the question rises that here at bank 0, we have R0. Here at register bank 1, we have R0. Here we have at 10 R0. And here at address 18 of RAM, we have R0. Now how to differentiate that which register we have selected? In other words, it means, for example, if I write a program in which I write a command, let's suppose move R0, comma, hashtag 25. I will discuss about this in assembly and programming, that what this is instruction for. But generally, move instruction is utilized to store any information, any value in the given destination register. Here the destination register is R0. It means copy a value of 25 in register R0. Mathematically, this will be represented as R0 equal to 25. It means now I am assigning 25 to R0. In assembly, we write it like move R0, comma, hashtag 25. So in which R0 this value will be written? Now that is the question. Will it be R bank 0, bank 1, bank 2, or bank 3? Now to clear this confusion or to clear this point, by default, it will be written in bank 0 by default, because in the previous slide we discussed whenever 8051 is powered on, whenever you are targeting R0, it means it will select bank 0. But let's suppose we have powered on, we have done a lot of processing, and now we came to a conclusion that how this will work. So to do this, we have a special function register This register is called PSW. PSW stands for Program Status Word. Now this is an SFR. This is a special function register. This is also the size of this register is 1 byte. In other words, 8 bit. This is the MSB bit, this one, and this is the LSB BCB. Understood? Now in this register, if we start from location 0, then 1, then 2, then we have 3, 4, 5, 6, and 7. So at location 3 and 4, we have 2 bits, RS0 and RS1. These are basically register select bits. So 2 bits means 2 to the power 2. We have 4 combination of selections. So 0, 0, when you write 0, 0 in it, then it means register bank 0 is selected. When you write 0, 1 in it, it means register bank 1 is selected. When you write 1, 0, it means register bank 2 is selected. And when you write 1, 1, register bank 3 is selected. The other bits we will discuss later in the course. So it means that the previous slide, the instruction that we have written, sorry, it means in the so it means this is select the data we have written will give us the register bank. Sorry, there was an interruption with the internet again. Now, how to write data in it? How to access the bank? For that, very easy. We have to bit address those bits RS1 and RS2. The location we already discussed, location 4 and 3. That bit D4 and D3 of PSW program status word are used to select the desired register bank. Now use the bit addressable instruction, set bit and clear. This stands for set bit. Understood? CLR stands for clear. Understood? So when you will use set bit, let's suppose I use an instruction set bit PSW dot 4, and similarly I use clear PSW dot 3. So it means I am setting RS1 to 1 here, and I am clearing RS0, which means this is 0. I am selecting register bank 2. So when this command will be executed after selection, when we execute this command R0 hashtag 25, then this means this 25 will be moved to R0, but that R0 will be in register bank 2. That means it will be here in the register bank 2. Understood? That's how we can switch between from one bank to another using this instruction. That's all about the introduction of RAM.